Okay, we'll be looking now at section 11.2, which is dealing with surface areas of prisms and cylinders. Now we are kind of skipping section 1, but I'm going to talk about the important parts in this lesson. The first thing is defining a polyhedron. A polyhedron is any three-dimensional space where each surface is a polygon. Okay, so polygons will be flat, they have straight edges. So we have no curved surfaces on a prism or a polyhedron. So prism would be a polyhedron where we have two bases that are polygons, and then all of the sides are going to be a parallelogram, okay, because all these sides are coming up, so they're going to be parallelograms. We'll often be looking at right prisms, and so they're actually going to be rectangles going around the sides. We could have any number of shapes. Notice this one, any of these sides could actually be the bases depending on what we want to do. But usually we'll be looking at something like, say, a triangular solid. All the other sides are rectangles, so we know very clearly that the bases are the sides that are not rectangles. We could also have a pyramid. A pyramid is whenever we have some polygon for the base, but all of the lateral faces are triangles. So here's some names for some common polyhedrons. We might have a prism. Now this is a triangular prism. It's named triangular prism because the bases are triangles. But notice going around we have all rectangles. This could be a rectangular prism because the bases are rectangles. Or a pentagonal prism because the bases are pentagons. We could also have a pyramid. This pyramid, the base down here, because this is the only side that's not a triangle. And so this would be a square pyramid because the base is a square. We could also have maybe a pentagonal pyramid and so on. We also have some curved shapes. Now these are not polyhedrons because they're curved. They don't have polygons as their faces. The first one would be a cylinder, which has a circle for each base, and a cone where we have a circle. We only have one base. So notice the main difference between the cylinders and cones would be, and same thing between a prism and a pyramid, is that pyramids are coming to a point and cones are coming to a point. But with prisms and cylinders, we have two bases that are the same. Some of the problems the book will have you do, they want you to identify the solids. Really the most important thing to recognize is the difference between a prism or a pyramid. This one, all of the lateral faces are triangles. We're coming up to a point, so we're dealing with a pyramid. We also have a square for our base, so we can say it's a square pyramid. The other important thing is that we're identifying the base, and the base of this is a square ABCD. The other things I'm not as concerned about on these. The other part I'm not as concerned about identifying the faces, edges, and vertices. You should know that vertices are the corners, edges are the lines, and faces are just all of those shapes, triangles and rectangles. For the next one, we want to identify the base also. If it is a prism, which we recognize as a prism because we have all these rectangles going around this way, then the sides we're looking at for our bases are the sides that are not rectangles. Since we have triangles for sides, those right triangles are our bases. The most important thing for finding surface area and the lateral area is just thinking about each of these faces as a shape that we could find the area of, because these are all polygons. These are shapes that we found areas of before. So we want to know some of the vocabulary here. Lateral faces are talking about the sides that are not the bases. So on this one we have the bases as these two hexagons. So the lateral faces are all the rectangles going around. Another important thing here is that we have a right prism. Now a right prism is different than Now a right prism is important because the bases are coming up at 90-degree angles, which is actually what makes these rectangles. We'll talk more about that later. To find the lateral area and surface area, then, we could think about these as nets. Remember, we're just adding the area of all the parts of this. So if I look first at the base of this and I have a hexagon, I can start by drawing that hexagon. And then I think about how these rectangles wrap around that. Now if I have a chain of rectangles wrapping around this, notice that they form one big rectangle. Think about a box. If you cut the top and bottom off, you would just have one big rectangle left over. And then we have the bottom base tagged on at the bottom. So to draw, we could just draw the base, which we did up here on top. We could draw the lateral area as a big rectangle. We could label the parts. If I have 6 sides, then I would have actually 6 rectangles here, but we could think about it as one big part. And then I could draw the other base down here, which just kind of corresponds to the other base. And if we're going to find the area, I mean, we might want to find the perimeter of the base, which is going to help us to identify the length of this side of this rectangle, which is going to help us find the area. So lateral area is ignoring the bases. It's just the sum of the area of the lateral faces. So I'm not looking at this side. Okay, we have two bases here, these blue parts, but it's this yellow part wrapping around that would be the area. So as we saw in this one, since this red side here wraps around the base, that's actually the perimeter of the base. And so to find the lateral area, I'm just going to take that perimeter here, the perimeter of the base, that's P. We get that by adding up A, B, C, and D, which are the sides of the base, and we multiply them by the height of that rectangle, which we'll call H. That's also the height of my prism. So lateral area is just perimeter times height. So if I'm asked only to find the lateral area, we could think about this thing. We've got a pentagon here. I could draw these shapes wrapping around here. Notice that's just going to give me one big rectangle where I have 5 sides. All of those sides, since it's a regular pentagonal prism, will each be a length of 14, which means the perimeter of my base is going to be 14 times 5, which is 70. I could also tag on the other base here, but we're not really worried about the base. Since we're looking for the lateral area here, we're only worried about this part. So my lateral area, my formula is equal to perimeter times height. My height in this one would be the side that's not connected to the base, and that would correspond over here. My perimeter, the 70, would be corresponding to this side here, all of that. So we're just going to plug in the values we've got. We found the perimeter, 70. We know the height, 8. And so that's going to give us 560. We won't forget our units of centimeters squared. In this next example, we want to find the surface area. Now the surface area is different from the previous example because this was only looking at the part going around, but now we want to also include the bases on this. So we'll do that by taking our lateral area and then adding 2 bases. And we're going to use SA for surface area. Some books will use something different, but SA is a good one. Surface area of this triangular prism. So let's first think about our base. Notice this right angle here. So when I draw it flat, I'm going to draw it very clearly that I have a right angle here with sides of 8 and 9. Notice we do not know the hypotenuse of this. We'll come back to that. Then wrapping around this, we have sides of 5. And notice that this side here would wrap around over to this side. And this side would wrap back around to that 8. And so we get a long rectangle where we have the perimeter of the base, but we don't know this side yet. And then we would have another triangle right here. So notice we're going to have the lateral area, the big rectangle, plus 2 bases. So the first thing we should do is think about the lateral area, which is equal to the perimeter times the height. And we have the height already right here, which we can see down here also as 5. So we can go ahead and plug that in. But we need to find the perimeter of this. So to do that, we're also going to need to find this third side. Since we have a right triangle, we can do that. If we think of this perimeter as x, we have x squared is equal to 8 squared plus 9 squared. And that will come to x is about 12.04. Now I kept more decimals than I need to so that my final answer will be a little more accurate. So my perimeter, 12.04, we can plug that into our lateral area formula over here, which is going to come to 145.2. Now we're not finished yet because we're asked for the surface area. We needed it because this is our formula up here. So for my surface area, I have my lateral area, 145.2, but I need to add 2 bases. So remember, my bases were these triangles here, so I should also do this off to the side somewhere. We need to think about what shape we have. So each one of these is going to be different, so that's why we just use a capital B here. But in this case, I can see I have a triangle. Area of a triangle is 1/2, base times height. Notice that this h is not the same h that we use for this. We're talking about the 8 and the 9 only. So using this 8 and this 9, the area of our base will be 1/2 of 8 times 9, or 36. And so I'll plug that in to my formula. We have all the pieces we need to find the surface area. If we add that together, that comes to 217.2. Make sure you include units of inches squared. So one thing that we need to pay attention to on these, I did mention this earlier, but I want to draw attention to it again, is that we need to have right angles here. We need to have our sides, our heights coming straight up from the bases in order for these formulas that we're using to work. Otherwise, we'd have to take each side individually and figure them out. We might have what's called an oblique prism or an oblique cylinder, where these things are pushed off of the perpendicular, so they're coming up at an angle. And these formulas that we've just learned are not going to work for these shapes here. Now next we're going to look at a right cylinder. And I want you to notice that the formula for the right cylinder is pretty much the same as the formula for the rectangular prism, except that our base here, our curve, it's a circle, so the area of the base would be pi r squared, because we're looking at the area of a circle. So notice how the lateral area wraps around here. We still would unroll this to be a rectangle. Think about unrolling a tissue tube or something like that, and we're going to end up with a rectangle if we cut that straight down the side like that. And the way that it wraps around the base would be its circumference. And so rather than using perimeter, we're going to use circumference of the base, which is 2 pi r. So my lateral area is circumference times height. Surface area then would be that lateral area, and then 2 times the area of the base. So we can still think of this thing as lateral area plus 2b. We can still think of the lateral area as perimeter times height, except for circles we use circumference rather than perimeter.